Our research investigated forest community ecology and tree growth in Point Pleasant Park following Hurricane Juan. Point Pleasant Park was part of an area traditionally known as Amdugadi, meaning spiritual place or the place of spirits. It was an important gathering place for the Mi'kmaq people. The location has recently been used as a public park, where it was kept as a protected forested area, containing an old and well-established ecosystem. The park was hit hard in September of 2003 when Hurricane Juan uprooted thousands of trees and irrevocably changed the park's forest community. While saddening, this event gave a special opportunity to observe the long-term impacts of this disturbance and the physical and biological changes in this forest community over time. Students from Dalhousie's Biology 2060 class collected data from established sites from 2004 to 2024. Our research questions included 1. How has the overall forest community changed over time and why? What we predict will happen to the overall community as the forest moves forward in its climax community and why. Number 2, how has the density of the dominant species in 2004 as well as the dominant species in 2024 changed over time? Why and what we can predict what will happen to the dominant species as the forest moves towards its climax community and why. And number 3, how has the chosen community metric changed over time? Why and what we can predict will happen to these chosen community metrics as the forest moves towards its climax community and why that is.
All right, so firstly, we're going to start off by listing our null and alternate hypotheses for data collected and calculated from 2004 to 2024 in Point Pleasant Park following Hurricane Juan in 2003. Our total density and species richness calculated are not going to experience any positive significant increase from those years. The alternate hypothesis for this is that they will experience a significant increase. For our red spruce and red maple populations, there will be no significant increase in total density. The alternate hypothesis would be that they do experience a significant increase in total density. And then for the Shannon Diversity Index, there will be no significant increase from 2004 to 2024. Same goes for Peelo's Evenness Index. And the alternate hypothesis is, of course, that they do experience a significant increase. The null hypothesis we will eventually either reject or fail to reject.
After Hurricane Juan, tree populations in Point Pleasant Park were surveyed. 6 20-meter by 20-meter sites that were most affected by the storm were chosen. You can see those locations here on the photo. Starting in 2004, every fall semester, students from Bio 2060 have gone out and collected information about the trees. 2 tapes of data were collected at each site. First, tree density per species, and second, tree size, measured at breast height. To be considered, trees had to be at least 2.5 centimeters in diameter. To analyze this data, linear regression graphs were used to show density, species richness, Shannon's Diversity Index, Peelo's Evenness, and average diameter at breast height. The amount of red spruce and red maple trees were also measured at each site. Linear regression was chosen to express the data as it allows us to make clear connections between all the dependent variables, as well as giving us the R-squared value to show us how much these dependent variables are related to the passing time. And finally, it allows us to make predictions on succession and future tree growth by observing what trend the line of best fit is showing. Using a linear regression analysis, the total densities of species in Point Pleasant Park was measured over time. From 2004 to 2024, there was a steady increase in density, with the total density from all sites in 2004 being 19 versus 518 in 2024. With an R-squared value of 0.49, there is moderate evidence that as the independent variable time progresses, there is an increase in the dependent tree density variable as well, proving that over time the density of trees increased. Using this data, we can predict that the density of forest will continue to grow steadily until a saturation point is hit. There are only so many resources available to support the trees. Once the carrying capacity is reached, tree growth will slow and then level off. To give even better insight on overall forest community changes from 2004 to 2024, we can observe the Shannon's Diversity Index. Shannon's Diversity Index shows the diversity of a community considering species richness, evenness, and diversity. The graph shows the diversity index increasing, but the R-squared value is only 0.33, meaning there's only a low to moderate correlation between time and diversity. Therefore, we fail to reject the null hypothesis, meaning that diversity, though may be affected by time, is most likely affected by other factors as well. Though the R-squared value is low, seeing a steady increase in the diversity index on the graph helps us predict that the Shannon's diversity index will continue to increase as the forest recovers. With the density of many different species increasing at many different sites, as seen on the last slide, the forest will continue to become more and more diverse.
Here, we are looking at how the density of red spruce has changed over time. Red spruce was the dominant tree species in Point Pleasant in 2004, following the hurricane, with an average of 3.25 individuals for the 4 surveyed sites. In 2025, 5 sites were surveyed, with an average of 8.8 individuals found at each site. While there is a general increase in the individuals per site over time, we found an R-squared of 0.12 for this model, indicating that this linear equation is not strictly applicable in the future populations of red spruce at the park. This means that we failed to reject our null hypothesis of red spruce in Point Pleasant Park not having significant increase in total density. This low R-squared is likely caused by the differences in chosen observation sites. While some of the sites are probably dominated by red spruce and continue to have a large number of individuals, other sites have less individuals due to factors like competition or environment. These sites with less red spruce likely contain higher numbers of other tree species, like red maple, which was the overall dominant species of the 2024 sites. Red spruce in Point Pleasant Park will likely continue to increase as the community continues to recover, specifically in sites with a large abundance of this species, before eventually they should reach a carrying capacity and level out in numbers.
All right, so we're going to talk about the dominant species in 2024, which was the red maple. First off, how did the population change from 2004 to 2024? Well, the 4 sites measured in 2004 after the hurricane, there were 0 individuals counted. And now in 2024, there were about 32 individuals per site. This peaked in 2019 with around 56 individuals over the 5 sites. And the total significance of our regression analysis that was done was R-squared is given by 0.16. This shows a insignificant or weak relationship with time. Likely the population changed this way because more red spruce had survived the initial hurricane, but the red maple had maybe a shorter generation time and proliferated more over the course of the years. A prediction we can make based on the data there is that likely the population will either grow or decrease in the following years. So the increase seen from 2004 to 2024 cannot be extrapolated to future populations because of the insignificant data. And it will likely stabilize around a carrying capacity soon that is either slightly higher or lower than the current total density. In regards to our null hypothesis, we failed to reject the null hypothesis that there is no significant increase in the total density of red maple.
We used a linear regression analysis to examine the effects on the species richness of trees in Point Pleasant Park over time since Hurricane Juan in 2003. There has been an increase in average species richness at the forest plots in Point Pleasant Park from 2.5 per 400 meters squared in 2004 to 9.2 per 400 meters squared in 2024. With an R-squared value of 0.6051, there's a moderately strong positive relationship between species richness of trees and time since the hurricane, indicating an increase. With that information, we can reject the null hypothesis that there's no relationship between species richness and time since the hurricane. This leads us to predict that species richness of trees will continue to increase over time as it has been for the last 20 years. This is because each year the habitat is slowly recovering from the effects of the hurricane and more trees are growing. However, the species richness should level off when the populations reach their carrying capacity. We would predict that this will be the same species richness as before the hurricane. We used linear regression analysis to examine the effect of Hurricane Juan in 2003 on the Pylus evenness of trees in Point Pleasant Park over time. There has been a slight decrease in average evenness at the forest plots in Point Pleasant Park from 0.94 in 2004 to 0.58 in 2024. With an R-squared value of 0.411, there is a weak negative relationship between Pylus evenness of trees and time since Hurricane Juan, indicating the relationship is not significant. We failed to reject the null hypothesis that there is no relationship between Pylus evenness and time since Hurricane Juan because the relationship found was too weak. This means we cannot confidently predict any changes in evenness for the forest plots in the future. The null hypothesis for only 3 of our variables was rejected, indicating that there has been only some growth and recovery in the forest plots of Point Pleasant Park since Hurricane Juan. We predicted significant positive relationships with all of our variables and time since the hurricane, but that is only true for the density, the red spruce, and the species richness. The hurricane did not add, remove, or cover new substrate in the area, leading us to assume the park has been in secondary succession since the event. Because it has been 20 years since, and the forest is only showing moderate amounts of growth, we predict that it is in the middle stages of succession. Because Point Pleasant Park is an urban park, it has some advantages for recovering from disasters. Because of the frequent visitors and effects from being in a coastal environment, the park is more resilient and able to recover faster. It has been thought that invasive species could hinder the park's ability to regrow its native species. However, that has not been proved to be an issue so far. One way that traditional knowledge and teachings from First Nations can aid in the way we view this study is through two-eyed seeing. Typically, when trying to track the recovery of a park, we would think of it in humans' best interests because we're the ones using the park. However, it is important to recognize that the land is not here for us. There are also lots of plants and animals that use Point Pleasant Park as their habitat. It is important to remember as we track the recovery of the park that we are aiming for the land to be healthy, not for it to be used for just humans.
We'd briefly just like to thank Allison Schmidt and Josh Rollins, as well as all the old ecology students and professors and anybody else that helped collect the data the past 20 years. And finally, here's our reference list. Thank you so much for listening to our presentation.